This is Algebra 2, Unit 4, Lesson 11 on solving exponential equations using logarithms. Okay, now we've solved some exponential equations already using the method of common bases. Now this technique is quite limited because it requires the two sides of the equation to be expressed using the same base. Now you can actually solve equations that do not have the same base by using the third logarithm law. Okay, now the third logarithm law is when you have log to the base b of a to the x, when you have an exponent. The rule says when you have an exponent, it's multiplied x times the log b of a. So remember, the exponent goes out front. That's the third logarithm law. Okay, so let's look at the common bases first of all, and then look at the logarithm approach. All right, so we're going to solve 4 to the x equals 8 using common bases. All right, so what we learned on that before is that we get the same base, then the exponents must be equal. All right, now how can we rewrite 4 is a base and an exponent? It would be 2 squared. Okay, and then that's raised to the x. And then 8 is 2 to the third. So this would be 2 to the 2x equals 2 to the third. So 2x is equal to 3 because if the bases are equal, the exponents are equal. And x is equal to 3 over 2 or 1.5. Okay, now the logarithm approach. The logarithm approach says what we're going to do is we are going to take the log of both sides. Okay, so we're going to say log of 4 to the x is equal to the log of 8. Okay, now to get the x down as the exponent, because remember a logarithm is an exponent, we're trying to figure out what the value of the exponent is. All right, the exponent rule or logarithm rule says this becomes x, it goes out front, becomes x times the log of 4 equals the log of 8. All right, so all we have to do to solve for x is divide by the log of 4. All right, so x is equal to the log of 8 divided by the log of 4. Now these are common logarithms. So all we have to do is take log of 8 and log of 4 and put it in our calculator. All right, so we have log of 8, use the log key, close your parentheses, divided by the log of 4. Okay, that's what's on my paper. And I have, look at that, it's 1.5. So x is equal to 1.5. So I got the same answer. Now, you could solve any exponential problem like this. Common bases is easier if you can do it, but you can't always use it. The beauty of this logarithm law is it removes the variable from the exponent. This law, in combination with log base 10, which is the common log, allows us to solve almost any exponential equation using calculator technology. So, we don't have to have common bases to find out what the exponent is, but if we have common bases, it makes your life easier. But they don't always work out that way. So let's take a look at some more problems using the logs. All right, so let's solve each of the following equations for the value of x. Round your answers to the nearest 100. Okay, now 5 to the x equals 18. There is no way that we can take a base of 5 and raise it to a power and get 18. It doesn't work. So, but 5 to some power is equal to 18. It's just not going to be with a common base. So what we want to do is take the log of both sides. What you do to one side of the equation, you've got to do to the other. So if I take the log of one side, I've got to take the log of the other side. All right, now this is the exponent. So the exponent is the power, so multiplied. X times the log of 5 equals log of 18. All right, and then we should divide by the log of 5. So x is equal to the log of 18 divided by the log of 5. All right, I'm going to put that in my calculator. Log 18 divided by log 5. All right, and rounded to the nearest hundredth, this will be 1.80. Okay, so if I do 5 to the 1.80, it should be approximately 18. Let's see if it is. 5 raised to the 1.80. That's pretty close to 18. Now remember, we rounded this. If I had raised it to this actual number, 5 raised to the, say if I went to this actual number before I rounded it, enter, I do get 18. So you can see there, because I rounded it, it's going to be a little bit off, but you can see that 5 raised to the 1.795888947 is actually equal to 18. Okay, let's try another one. 4 to the x equals 100. All right, can we raise these to a powers? Do you know what the base you could be? Well, you could do a base of 2, but it won't work that well. But if we do log of both sides, log of 4 to the x is equal to the log of 100. Okay, so this will be x log of 4 is equal to the log of 100. All right, so solve for x, divide by the log of 4, log of 100 over log of 4. Actually, you should know what the log of 100 is. It's 2, but we can put this whole thing right in the calculator. All right, grab my calculator. Log of 100 divided by the log of 4. And it equals 3.3219, so rounded to the nearest hundredth, it'd be approximately 3.32. And there's your answer. Okay. Last one. 2 to the x equals 1560. Take the log of both sides. What you do to one side, you must do to the other. Okay. The x goes out front. X times the log of 2 is equal to log of 1560. And then divide by the log of 2. So we have log of 1560 divided by the log of 2. Grab your calculator. Log of 1560 divided by the log of 2. All right, so here we go. Rounded to the nearest hundredth will be 10.61. So 10.61. So there we go. So if you can get the exponent by itself on one side, you can take the log of both sides and solve the equation. So these equations can become more complicated, but each and every time we'll use the logarithm law to transfer an exponential into one that's more familiar. Okay, so 6 to the x plus 3 equals 50. Let's solve it. We want to take the log of both sides equals the log of 50. All right, use the exponent rule, which x plus 3, I'm just going to put in parentheses so I don't accidentally do something I shouldn't. All right, and this will be log of 6 is equal to the log of 50. All right, now I want to solve this for x. So I'm not going to, I can distribute this if I want to, but I'm going to just divide this. So I'm going to say x plus 3 is equal to the log of 50 over the log of 6. And then how do I get the the x by itself? I have to move the 3. Well, I'd subtract the 3 on both sides. So x is equal to the log of 50 divided by the log of 6 minus 3. All right, now, when I put this in my calculator, I've got to put this entire thing in. So I can even make it look like what's on the calculator. All right, now, since it's log of 50 divided by log of 6, I can put it in as the alpha key, alpha y equals, and use as a fraction. And it would be log of 50 divided by the log of 6. And then finish the fraction by using the arrow key and then minus 3. And I get rounded to the nearest hundredth is going to be negative 0.82. Okay, so this is negative 0.82. Now, if you don't want to use the alpha key, you can enter it together as like we've been doing, log of 50 minus log of 6, or divided by log of 6, sorry. Divided by log of 6. Get that answer first, enter, and then minus 3 from it. Okay, so you do get the same answer. It's a little faster to enter one way or the other. It's whatever way you're most comfortable with, but you can do it both ways. Okay, so let's try this one. 1.03 to the x over 2 minus 5 is equal to 2. All right, I want to take the log of both sides. Log of 1.03 to the x over 2 minus 5 is equal to log of 2. All right, the x to 2 over 2 minus 5 goes out front. I'm going to put in parentheses so I don't accidentally multiply something I shouldn't. Log of 1.03 is equal to the log of 2. All right, I want to get the log by itself, or excuse me, the x by itself. So I want to divide by log of 1.03. So this is x over 2 minus 5 is equal to the log of 2 over the log of 1.03. All right, now how am I going to get the x by itself? Well, first of all, I'm going to have to add the 5. So that gives me x over 2 equals log 2 over log 1.03 plus 5. All right, now how do I get rid of the 2? Well, then I have to multiply both sides by 2, but remember I have to multiply everything by 2. So this is going to be x is equal to 2 times the log of 2 over 1.03 plus 5. Okay, when I enter it in my calculator, it should look like this. Oops, a log of 1.03, I forgot the log. Okay, so when I enter it in my calculator, it should look like that. All right, so 2, parenthesis. I'm going to use the alpha key. All right, it would be log of 2, close your parenthesis, over log 1.03. All right, now forward arrow plus 5, and then close your parenthesis. There we go. So that looks like what's on my paper, and I end up with, rounded to the nearest hundredth, I get 56.90. All right, so x is equal to 56.90. All right, so it's just solving the equation. Okay, so I'm going to skip over exercises 4 and 5. We're going to do those in class the next day, and let's take a look at exercise 6. All right, find the solution to each of the following exponential equations in terms of a logarithm with the same base as the exponential equation. All right, so basically what we want to do is we want to do the figure out what the x is. So first thing we want to do is we want to get this to be a single exponent, base and exponent. So we've got to move some stuff. So first thing we have to do is move the 3. That gives me 4 times 2 to the x is equal to 20. All right, now I want to get the base of 2 by itself, so I'm going to divide by 4, and I get 2 to the x is equal to 5. All right, now, if I want, in terms of logarithm with the same base as the exponent equation, the logarithm would be, instead of log to the base 10, it would be log to the base 2. So let's do that. Log to the base 2 of 2 to the x is equal to log to the base 2 of 5. I can do that because I'm doing the same thing to both sides of the equation. All right, now, we want to follow our exponential rule, so the exponent of x goes out in front. So x log of 2 is equal to log to the base 2 of 5. All right, what's log to the base 2 of 2? 2 to what power is 2? Well, it's actually going to equal 1. So this is actually x times 1 is equal to log to the base 2 of 5, because an exponent raised, or excuse me, a logarithm raised to itself is equal to 1. So x will equal log to the base 2 of 5. There we go. All right, let's try one more. All right, we want to get the exponent, or the base and exponent by itself, so we divide by 17. All right, 5 to the x over 3 is equal to 4/17. Okay, now the same base as the exponential equation, I want to use a base of 5. So I'm going to use log base 5 of 5 to the x over 3 is equal to log to the base 5 of 4/17. Okay, exponent goes out front, x over 3 log to the base 5 of 5 is equal to log base 5 of 4/17. And we know log to the base 5 of 5 is equal to 1, so this is going to be x over 3 is equal to log to the base 5 of 4/17. So all we have to do is multiply both sides by 3. And x will equal 3 times log to the base 5 of 4/17. And there we go. All right, so that is solving exponentials using logarithms.